In this lecture, we're going to define the atom by the definition given by Democritus and by Dalton's atomic theory. So to be able to define atom, an atom is the smallest particle of an element that retains its identity in a chemical reaction. Be able to compare theories about the structure of an atom. We're going to start with Democritus and Dalton, and you will later compare it to other theories. Be able to develop models that describe atomic composition. That's what this whole chapter will be about. And identify how atoms are conserved during a chemical reaction. Dalton did this very well. You can see here atoms. So this is with a scanning tunneling microscope, and in 1989, IBM, International Business Machines, demonstrated the ability to manipulate and move individual atoms. So they're kind of showing off what they can do here by writing their own letters in things that are only 5 atoms large. And that's going to be xenon atoms on a chilled nickel crystal. Now, of course, you can't see the nickel atoms because the resolution is too low. So imagine you're looking at something from space and you put a bunch of rocks on the sand. You can see the individual rocks, but you can't see each one of the grains of sand. That's just the resolution of what you're seeing. Democritus was the first one to come up with the idea of an atom. So this is a Greek philosopher. And he had a lot of writings, but none of them survived. Stupid fire in Alexandria. Democritus basically had this idea. Let's say you have a bar of iron, and this bar of iron can be broken in half. And then that bar of iron can be broken in half again, and you can continue dividing it. But at some point, it's going to be the minimum size possible and still be iron. If you were to divide it any farther, it would not be iron. This minimum size possible is the atom. Atoms must be indivisible and atoms must be indestructible because you can't just destroy these elements. So that was basically Democritus's idea, and that was all we really knew of atoms for over 2,000 years. Then Dalton came along and did some science. You can see him thinking there. He studied the ratios of reactions. If you apply electricity to water in both a positive and negative side, you're going to see bubbles come off of each side. This is actually dividing water in a reaction called hydrolysis. So for that, you're going to get 2 gases, and the amount of gas in one side is going to be twice the amount of gas on the other side. So there's 2 gases that water is breaking down in, and that's a 2-to-1 ratio. Neither of those gases can be further divided, so those must be individual elements. And he saw those elements would have to be of atoms. So here's Dalton's atomic theory. First off, atoms make up all matter. Everything that is made of atoms. If something isn't, then it's not made of atoms. Atoms of the same element have to be identical. So that means in order to be identified as the same thing, they have to be, well, the same properties. Atoms are permanent and indivisible. So you can probably think, wait, I have an idea of what about splitting atoms? Way later. And for now, we're going to look at the atoms cannot be created, divided, or destroyed. Atoms of different elements can combine to form compounds in simple whole number ratios. And we're going to see this later in stoichiometry when we hit the end of the school year. We're going to be looking at these whole number ratios. For example, 2 oxygens and 1 carbon are going to make carbon dioxide. 2 hydrogens and 1 oxygen are going to make water, H2O. And this is just the rearranging, combining, and separation of different chemicals in different reactions. So that's going to be the rearranging of atoms in that reaction.